Hello, my name is Tyler Witt, and I'm in the Industrial and Equipment Systems Applications team inside the MSP430 Microcontroller Business Unit.
And I'm Rafael Mena, also a part of the MSP430 Microcontroller Industrial and Equipment Systems Applications team. We're here to talk to you about the MSP430 Microcontroller Industrial Communications portfolio. Tyler, what are some of the industrial communication protocols that we support?
Today, we're going to talk about a few different industrial protocols. At the heart of the portfolio is the 4 to 20 milliamp wired loop solution, which is the primary standard in most industrial applications. We then have the wired HART protocol, which essentially superimposes a digital signal on top of the 4 to 20 milliamp wired loop. Finally, we have the IO-Link solution. This solution is also a wired loop communication protocol, but instead of current, the physical layer is based on a 0 to 24 volt interface.
We have a few different implementations of the 420 milliamp loop. Would you mind telling us about them?
Sure. We have both a multi-chip and single-chip implementation. On the multi-chip implementation, we have a reference design based on two different form factors as shown here. The sensor output is sensed via the 24-bit ADS-1220, while the physical layer is provided by the 16-bit DAC 161S997 device. In this case, the FRAM-based MSP430 FR5738 provides processing and logging of the sensor data, system management and handling of the 4 to 20 milliamp communication loop. A second implementation is based on a single-chip MSP430 solution. It is a very cost-effective system solution. This MSP430 single-chip implementation leverages the integrated smart analog on the MSP430 F2274. This device has two configurable operational amplifiers, a 10-bit 200 kilosample per second analog-to-digital converter, and two 16-bit timers capable of supporting multiple capture compares and pulse width modulation outputs, plus many more peripherals. For this design, we use one operational amplifier to sense the sensor output and provide signal conditioning capability, and the second operational amplifier to modulate the current in the 4 to 20 milliamp wired communication loop. The 10-bit analog digital converter digitizes the sensor output for further processing.
This is a great example of how we've been able to leverage the integrated analog on the MSP430 family of devices. How about HART? Can you tell us a little bit more about that protocol?
Sure. We have two implementations based on the Launchpad booster pack format. This reference design, which uses the MSP430 FR5969 Launchpad, provides full digital HART protocol functionality and, in addition, integrates the modem functionality into the MSP430 by once again leveraging the integrated smart analog on the microcontroller. Using timer modules and the 12-bit analog-to-digital converter on the MSP430 FR5969 device, we are able to modulate and demodulate the FSK signals of the physical layer in the HART protocol. What is typically done with two chips, we are able to do with the MSP430 single-chip solution.
Another great example of how the integrated smart analog on the MSP430 leads to the most cost-effective system solution. To wrap up, can you tell us a little bit about our MSP430 implementation of IO-Link?
Sure. This multi-chip implementation leverages the performance of both the 24-bit ADS-1220 analog-to-digital converter for sensing of the sensor signal and the IO-Link PHY-layer device, the SN65HVD101. In this case, the IO-Link stack runs on the MSP430 FR5738 FRAM-based microcontroller. This TI design offers a rapid prototyping platform for an IO-Link sensor transmitter. The entire solution fits in a 6mm wide PCB, compatible with the industry standard M12 connector.
Thanks, Tyler. To get further information on each of these reference designs, please visit the following URLs. Thanks for watching.